Hey there, tech enthusiasts! Let's talk about lithium batteries, the powerhouses of our modern world. From smartphones to electric cars, these batteries are everywhere. But here's the catch, they're divas about temperature. Just like us, lithium batteries have a comfort zone. Get them too hot, and you're looking at reduced performance, shorter lifespan, and even the risk of fire. Too cold, and they get sluggish and lose their mojo. That's where a cooling chamber comes in. It's like creating the perfect climate-controlled environment for your batteries to thrive. Think of it as a spa day for your power source. We're talking about maintaining that sweet spot, usually between 15 degrees Celsius and 35 degrees Celsius to keep those lithium ions happy and energized. The mission of a cooling chamber is simple. Keep those batteries cool and comfortable. But there's more to it than just blowing some cold air. First, we need to protect those batteries from the elements. Dust, moisture, and extreme temperatures are their kryptonite. A good cooling chamber acts like a fortress, shielding the batteries from harm. Next up, we need to manage the heat. Batteries generate heat when they're working hard, especially during charging and discharging. Our chamber needs to whisk that heat away before it turns into a problem. Finally, we need to be able to control the temperature precisely. Too much cooling can be just as bad as not enough. A well-designed chamber allows us to fine-tune the environment for optimal battery performance. Picture this, a high-tech safe for your batteries, designed to keep them cool, calm, and collected. That's our cooling chamber. Imagine a vault where your precious batteries are not only stored, but also pampered with the perfect temperature. This cooling chamber is like a spa for your batteries, ensuring they remain in optimal condition, ready to deliver peak performance whenever needed. Now let's break down the essential components that make this haven of temperature control a reality. Each part plays a crucial role in maintaining the delicate balance of temperature, ensuring that your batteries are neither too hot nor too cold, but just right. Insulating housing. Think of this as the chamber's skin. Made from materials like fiberglass or foam, it acts as a barrier, keeping the heat out and the cool in. This housing is meticulously designed to provide a robust shield against external temperature fluctuations, ensuring that the internal environment remains stable and conducive for battery longevity. It's like wrapping your battery in a cozy blanket that also happens to be fireproof. This protective layer not only insulates, but also safeguards the batteries from potential hazards, providing an extra layer of security and peace of mind. Air ducts and fans. Just like our lungs, a cooling chamber needs to breathe. These components are essential for maintaining a continuous flow of air, which is vital for dissipating heat and ensuring that the batteries remain at a consistent temperature. Ducts act as airways, channeling cool air throughout the chamber. They are strategically placed to maximize airflow efficiency, ensuring that every corner of the chamber receives an adequate supply of cool air. Fans keep the air moving, preventing hot spots and ensuring even temperature distribution. These fans are designed to operate quietly and efficiently, providing a steady stream of air that helps to maintain a uniform temperature throughout the chamber. Active cooling system. For those high-performance batteries that like it extra chilly, we bring in the big guns. An active cooling system. This system is engineered to handle the most demanding cooling requirements, ensuring that even the most heat-sensitive batteries remain cool under pressure. This system works like a refrigerator, using a refrigerant to absorb heat and pump it away from the batteries. The refrigerant circulates through a network of coils, efficiently transferring heat away from the batteries and maintaining a consistently cool environment. Optional Peltier plates. These high-tech plates offer precise temperature control in a compact package. They are perfect for applications where space is limited, but precise temperature regulation is critical. Using the magic of thermoelectric cooling, they can both heat and cool the batteries as needed, like a personalized climate control system. This advanced technology allows for fine-tuned temperature adjustments, ensuring that the batteries are always operating within their optimal temperature range regardless of external conditions. Section 4. Fans and filters, keeping the air flowing and clean. Remember those air ducts and fans we talked about? They're like the lungs of our cooling chamber, keeping the air fresh and circulating, but just like our lungs need filters to keep out dust and other nasties, so does our cooling system. We don't want any dust bunnies building condos in our battery chamber. Dust can clog up the system, reduce airflow, and even pose a fire hazard. That's why we install filters strategically placed within the air ducts. These filters trap dust particles, keeping the air clean and the batteries happy. They need regular cleaning or replacement, just like the air filter in your car. Trust me, your batteries will thank you for it. Section 5. Active cooling like a fridge for your batteries. Sometimes fans and filters just don't cut it. They can only do so much to keep things cool, especially when dealing with high-performance batteries that generate a lot of heat. When you've got high-performance batteries working up a sweat, you need to bring in the heavy artillery, an active cooling system. These systems are designed to handle the intense heat that these powerful batteries produce. Imagine a miniature refrigerator dedicated to keeping your batteries cool. Just like how a fridge keeps your food fresh by maintaining a low temperature, an active cooling system ensures that your batteries remain at an optimal temperature. That's essentially what an active cooling system is. It's a specialized setup that works tirelessly to prevent your batteries from overheating, thereby extending their lifespan and maintaining their performance. It uses a special fluid called a refrigerant that circulates through a closed loop, absorbing heat from the batteries and releasing it outside the chamber. This refrigerant is crucial because it has properties that allow it to absorb and release heat efficiently. This closed loop consists of three main components, each playing a vital role in the cooling process. 1. The compressor. This is the muscle of the operation, compressing the refrigerant and pumping it through the system. The compressor increases the pressure of the refrigerant, which raises its temperature, preparing it for the next stage. 2. The evaporator located inside the chamber. The evaporator is where the magic happens. Here, the high-pressure refrigerant expands and cools down, allowing it to absorb heat from the batteries. The refrigerant absorbs heat from the batteries, cooling them down. This heat exchange process is critical for maintaining the batteries at a safe operating temperature. 3. The condenser. This component releases the absorbed heat into the surrounding environment, located outside the chamber. The condenser cools the refrigerant back down, turning it into a liquid so it can re-enter the cycle. It's a continuous cycle of heat transfer, ensuring your batteries stay cool even under pressure. This system is essential for applications where battery performance and longevity are critical, such as in electric vehicles, data centers, and high-tech gadgets. By keeping the batteries at an optimal temperature, active cooling systems help prevent overheating, reduce wear and tear, and ultimately extend the life of the batteries. This means better performance and reliability for all your high-tech devices. Regular maintenance of these cooling systems is also crucial, ensuring that the refrigerant levels are adequate and that all components are functioning correctly can make a significant difference in the system's efficiency and longevity. So next time you think about battery performance, remember the unsung hero working behind the scenes, the active cooling system. It's like having a fridge for your batteries, keeping them cool and efficient, ready to power your world. Section 6. Peltier plates, high-tech cooling on demand. For those seeking the ultimate in battery temperature control, look no further than Peltier plates. These innovative devices are revolutionizing the way we manage heat in various applications, especially in the realm of battery technology. These marvels of engineering offer precise, localized cooling and heating without any moving parts. This means they are not only efficient, but also incredibly reliable, as there are fewer components that can wear out or fail over time. Imagine a thin, flat plate that can get cold on one side and hot on the other when you apply an electrical current. This dual functionality opens up a world of possibilities for temperature management in compact spaces. That's the magic of the Peltier effect. This phenomenon allows for a highly efficient transfer of heat, making it possible to achieve significant temperature differences with minimal energy input. By strategically placing these plates near your batteries, you can fine-tune their temperature with incredible accuracy. This is crucial for maintaining optimal battery performance and longevity, as batteries are highly sensitive to temperature fluctuations. Peltier plates are like having a team of tiny HVAC technicians dedicated to each battery cell. They offer several advantages. First, their compact size. These plates can be integrated into even the most space-constrained designs, making them ideal for modern miniaturized technology. Peltier plates are incredibly thin, making them ideal for applications where space is limited. Second, precise control. The ability to adjust the temperature with such precision ensures that each battery cell is kept within its optimal operating range. The amount of cooling or heating can be precisely controlled by adjusting the electrical current. This level of control is essential for applications that require rapid and accurate temperature adjustments. Peltier plates can quickly adjust the temperature, making them ideal for dynamic battery applications. Whether it's a sudden increase in load or a need to quickly cool down, these plates respond almost instantaneously. They are like the VIP treatment for your batteries, ensuring they stay in their comfort zone no matter what. With Peltier plates, you can be confident that your batteries will perform at their best, extending their lifespan and improving overall efficiency. This high-tech cooling solution is truly a game changer in the world of battery management. Section 7. Keeping an eye on things, monitoring and control. We've built this amazing cooling chamber, but our job isn't done yet. We need to make sure it's working correctly and keeping those batteries happy. That's where monitoring and control systems come in. Think of these systems as the brains of the operation. They constantly monitor the temperature, humidity, and airflow within the chamber, ensuring everything is running smoothly. We're talking sensors, thermostats, and control units working together to maintain the perfect environment. These systems can even send alerts if something goes wrong, like a sudden temperature spike or a fan failure. With real-time data and automated controls, we can ensure our batteries are always in good hands, or rather, a good chamber.